Hi, and welcome to the Military Magazine channel. In this issue, we will talk in detail about the armored vehicles of the British Army. Armored Personnel Carrier FV 4333 Stormer. The Sun newspaper learned about the UK's plans to transfer Stormer Alvis Stormer self-propelled artillery mounts to Kyiv, a modern military armored vehicle manufactured by the British company Alvis Vickers, now by Systems Global Combat Systems. The Stormer is an evolution of the CVRT family of vehicles, Scorpion, Scimitar, Spartan, etc. Essentially a larger upgraded version with an extra road wheel on each side. The UK is going to transfer Stormer anti-aircraft self-propelled guns equipped with Starstreak anti-aircraft missile systems to Ukraine, writes The Sun, citing sources. According to one of the interlocutors of the publication, British Defence Secretary Ben Wallace intends to make a statement about this before Parliament this week. According to The Sun, the Ministry of Defence demonstrated Stormer self-propelled guns to representatives of Ukraine 2 weeks ago at a training ground on the Salisbury Plain. They can be delivered to the country in the coming days on C-17 Globemaster military transport aircraft. These self-propelled guns are armed with 16 laser-guided anti-aircraft missiles. The vehicle was originally designed by the Military Transport and Engineering Establishment, which no longer exists as such, and the first prototype appeared briefly in a mobility demonstration at Bovington during the 1978 British Army Equipment Show. In June 1981, Alvis announced that its FV 4333 development had been designated Stormer. The Stormer took advantage of existing technology from the BAE Systems Land Systems Scorpion CVRT family, as well as many proven components. The body of the Stormer is wider than that of the CVRT, and its original gasoline engine has been replaced by a Cummins or Perkins Engines Company turbocharged diesel engine. In order to achieve a larger usable area and carrying capacity, in addition to various minor changes, a road roller 4.6 was added to the machine and it is equipped with an economical engine. The length of the vehicle has been increased from 4.36 meters to 5.27 meters. Vehicle weight, 13 tons. Speed, up to 80 kilometers. Crew, 3 people. The basis of the complex is the Starstreak HVM missile defense system with a warhead of 3 darts 0.45 meters long, 20 millimeters in diameter, weighing 900 grams, of which 450 grams of PVC-98 plastic explosive. Each of the darts has its own laser beam control and guidance scheme, an armor-piercing core, an explosive charge and a thermopile. The performance characteristics of Starstreak manpits: target engagement range from 300 to 7,000 meters, target engagement height up to 5,000 meters, maximum missile speed over 3 m, missile length 1,369 millimeters, launch weight of the missile 14 kilograms, warhead 3 penetrating tungsten sub-munitions. The Alvis Stormer Starstreak is one such modification that can carry 8 Starstreak high-velocity missiles for air defense. The Stormer tracked vehicle is a mobile platform for the Starstreak high-velocity missile (HVM) system, providing squad protection and superior mobility with 8 missiles ready to fire and 9 more stowed inside. The HVM system is a low-level close-in air defense (CAD) system with a fast kill capability designed and optimized to counter the threat of attack helicopters. The missile uses a system of 3 dart-type projectiles capable of inflicting multiple hits on the target. Each of these darts has an explosive warhead. The system is equipped with a root-mounted air defense warning device that provides target detection and prioritization. The panoramic weapon sight is located in front to the right of the vehicle. The Starstreak is manufactured by Alvis Air Defence, formerly Shorts Missile Systems, in Belfast, Northern Ireland. It is also known as Starstreak HVM, high-velocity missile. Once launched, the missile accelerates to over Mach 4, making it the fastest short-range surface-to-air missile in existence. It then fires 3 laser beam sub-munitions, increasing the chance of successfully hitting the target. The Starstreak has been in service with the British Army since 1997. In 2012, Alvis relaunched the system under the name Force Shield. Development of the missile began in the early 1980s after an evaluation of missile and cannon options to enhance air defense capability showed that a high-velocity missile system best suited the need and could also replace existing shoulder-launched missiles. The General Staff Requirements, GSR 3979, was drafted with a system requirement that specifies the requirements for 3 launch platforms for the missile: self-propelled launcher, lightweight 3-shot launcher, portable launcher. In 1984, the UK Ministry of Defence awarded development contracts to British Aerospace, BAE, and Short's Missile Systems. The BAE missile was known as the Thunderbolt HVM. The Shorts won the competition and received £356 million. Further development and a manufacturing contract were issued in November 1986, and the missile was officially put into service in September 1997. The missile was intended to replace the Javelin anti-aircraft missile in UK service. The LML and shoulder-launched versions have been in use since 2000. In July 2001, Alvis received a contract to build a successor to the Starstreak friend foe identification system. In mid-2007, Alvis UK and Northern Ireland announced that it had developed the Starstreak 2, a vastly improved successor to the Starstreak missile. Some of the benefits of the new version are: increased range to 7 km, 4.3 miles, increased lethality, improved guidance system and a much higher operating ceiling, up to 5 km, 16,000 feet. In 2011, when it won a contract to develop light multi-purpose missiles, LMMs, Alvis announced that it had agreed with the Department of Defense to reallocate previously agreed budgets to facilitate full-scale development, serial production, and deployment of the LMM. It is assumed that the contract was with Starstreak. Description: Starstreak is transported in a pressurized launch tube. The operator accompanies the target with the help of an optically stabilized sight of the aiming unit. The target tracking process allows the aiming unit to calculate the correct trajectory for the missile to approach the target. The operator can indicate the direction of the wind to the block and, in the case of a distant target, provide a turn. When initial tracking is complete, the operator launches the missile by pressing a button. The rocket then fires the first stage rocket motor. He fires a rocket from the tube, but burns out before leaving the tube to protect the operator. 4 meters, 13 feet, away from the operator, when the missile is at a safe distance, the second stage fires. This quickly accelerates the missile to a burnout rate in excess of Mach 4. When the second stage burns out, 3 dart submunitions are ejected. The body of the dart is made of tungsten alloy. Each dart is 396 mm, 15.6 in, long, 22 mm, 0.87 in diameter and weighs about 900 grams, 32 ounces, approximately half the weight of each dart. Approximately 450 grams, 16 ounces is its explosive charge, detonated by a delayed action fuse, to a non-rotating rear with 4 fins. The rear of each dart also houses the guidance electronics, including a rear-facing sensor. The darts do not target laser energy reflected from the target. Instead, the targeting unit projects 2 laser beams that draw a 2-dimensional matrix on the target. The lasers are modulated, and by examining these modulations, the submunitions sensor can determine the location of the dart and the matrix. The dart is then guided so that it remains in the center of the matrix. The striking elements are controlled by short-term braking of the rotating bow with the help of a clutch. The front fenders then guide the rocket in the right direction. The 3 submunitions fly in formation with a radius of about 1.5 meters, 4.9 feet, and have enough kinetic energy to maneuver, to meet an evasive 9 grams target at 7,000 meters, 23,000 feet. Earlier laser guidance systems used a single beam that was permanently held on the target, and homing with the missile's laser energy reflected off the target. If it moves away from the target, reflection will stop and pointing will be lost until the target is restored. This problem can be solved by making the laser beam wider, but at the cost of accuracy and reflected energy. The Starstreak system allows you to make the beam area much larger than the target, while maintaining high accuracy. Upon impact with the target, a delayed action fuse is triggered, allowing the projectile to penetrate the target before the high-explosive warhead is detonated. The tungsten hull is designed for fragmentation and maximum target destruction. In September 1999, The missile was demonstrated against an FV-432 armored personnel carrier, demonstrating the effectiveness of the missile as a surface-to-surface weapon. Each submunition dart flying at 4,500 km per hour, 2,800 miles per hour, has a kinetic energy comparable to a 40 mm Bofors cannon projectile, although it lacks the armor penetration of a dedicated anti-tank guided missile or coaxial projectile target missile, for example, air defense systems. Advantages: the Starstreak has several advantages over guided, radar-guided, and close radio-guided missiles, such as the blowpipe or javelin. It cannot be jammed by means of infrared or radar countermeasures. It cannot be suppressed by anti-radar missiles. Service history: the missile was adopted by the 12th Corps, the Royal Regiment of Artillery, in 1997 as part of a high-velocity missile (HVM) system equipped with both an air defense detection device, ADD, and a x-60 thermal imaging sight. Each regiment was equipped with 108 HVM self-propelled armored launchers mounted on a Stormer tracked chassis, capable of carrying 8 ready-to-launch missiles and a further 8 reloads. The original capacity of 12 was reduced in refinement. An armored version of the HVM self-propelled Stormer system was used during the Second Gulf War but did not fire. The British Army is currently using the 5th generation A5 missile, which is a significant improvement over the original missile. The HVM SP and LML variants now carry a combination of both the Starstreak A5 and light multirole missiles. In 2012, the Department of Defense announced that it would place HVM LML lightweight role-playing units equipped with Starstreak A4 missiles on the rooftops of several apartment buildings in London ahead of the London 2012 Olympics. The ministry said the area was the only suitable location for such an air defense unit. Some residents were upset and unsure of the need for a detachment. In 2013, the UK Department of Defense ordered 200 more Starstreak missiles. On March 16, 2022, Defense Secretary Ben Wallace announced that the UK would supply Ukraine with Starstreak missiles to help prevent Russian air supremacy following the Russian invasion of Ukraine in 2022. British soldiers trained Ukrainian troops on the system. In April 2022, Ukrainian soldiers used Starstreak missiles and Ukrainian forces were reported to have successfully used the system to shoot down a Russian aircraft combat helicopter Mi-28 Newtons. The missile, according to footage released by the UK Department of Defense, hit all 3 rounds, splitting the helicopter in half.